And I would like to mark the De Bruyn article as the next exhibit.
Exhibit number 835.
You would agree that there have been numerous improvements in wastewater treatment since 1998,
Is there a reason you selected the year 1998?
perhaps because of the 1998 study by Sylvester?
You've asked a question about wastewater treatment. Can you be a little bit more specific about what you mean?
Wastewater treatment from municipal wastewater plants.
Thank you, I appreciate that. And can you tell me what specific changes you're referring to in treatment processes that have improved since 1998?
The question is meant to be general. Do you agree or no?
I'm not aware of any specific changes in wastewater treatment, municipal wastewater treatment processes since 1998. If you're able to direct me at something that you're referring to, I would be delighted to look at it, but I don't know specifically what you're referring to.
If we could turn to page 63 of your report. You've mentioned that there's an improvement in water quality after 2003. However, you discounted the measured improvements. Can you say why you discount these improvements?
Yes, I can. What we found when we looked at the data for the Lower Fraser River Basin was that post 1993 was the year that as we understand it, was the year that responsibility for collection and collation of effluent quality data and surface water chemical monitoring around municipal wastewater treatment plants devolved to those to the GBRD and other regulated authorities within the province. And what we understood and what we observed when we looked in the EMS database is that after that time, the data that typically would have been collected and collated in that database by ministry officials was no longer in that database after that date for certain locations within the Lower Fraser River Basin. And so that's why we, although we observed certain changes in water quality index, particularly since 2003, we didn't believe that was real because it appeared that there was data missing for some key sites that would have incorporated discharges from wastewater treatment plants.
Now, yesterday you gave evidence that waste was increasing, and specifically wastewater, because the population increased. I put it to you that that is incorrect based on maps 9A and 9B of Dr. Johannes' report, and that solid and liquid waste volume is not increasing. So this would be technical report 12.
Could you refer me to a page, please?
Okay, it's exhibit 735, and it is in the appendix, and it's map 9A, which is page M21 and M22. If Mr. Lund could direct his attention to the table at the bottom of the page.
I see the results for solid waste. I assume that that's solid waste. We talked about several things yesterday, one of which was biosolids. I don't believe this is what we're referring to here. I believe this is essentially trash that is headed for landfills. Is that correct? What is in this particular graph?
That's my understanding.
Yes.
Okay, do you agree based on this chart that solid waste is not increasing?
What I see based on this chart is over the period, we have data, it looks like between 1990 and 2006, and it looks like the solid waste as measured in tons for 6 regional districts out of 10 within our study area. It's very hard for me to interpret this graph. So let me tell you why. As I look at the title, it says, and this is all I have to go on here, 6 regional districts out of 10 within our study area had available solid waste management data, which were included in these results. Less populated regional districts do not routinely monitor or have available time series data for solid waste disposal, including Nanaimo, Comox Valley, Powell River, and the Sunshine Coast. Data for these regional districts were not included in the results present. This doesn't tell me is what is included. But I don't know what this data is. I'm sorry. If you could, I haven't read this report. This is not one of the ones that I've looked at. Not in detail, not at all. And so, if you were able to tell me what the source of this information is and what it represents, I think we could have a discussion about it.
Okay, well, in the interest of time, we'll move to the next page then. And there are a number of charts which outline the liquid waste. And it also, in my submission, shows that liquid waste is not increasing. Can you comment on that?
Mr. Commissioner, I'm going to object to this line of questioning. The witness has already said that he's not read the report. We can spend a long time trying to discern what is meant, what the witness may discern from this report, but at the same time, at the end of the day, I'm going to suggest it's a useless exercise to go through, particularly given the fact that he's not read this report in depth and he doesn't understand how the data was derived.
In my submission, I have to put these to him because there's a disagreement between experts, and it would be unfair for me not to specifically put them. And if he says he hasn't read it, that's fine with me, but I wanted to be fair to the witness.
Well, what I would suggest then, counsel, in the interest of time, as you said, I don't know if you're coming to the end of your examination or not.
I am.
I was going to suggest that perhaps over the lunch break, he could look at this, and then right after lunch, he could just address this question once he's had an opportunity, at least to look at the report, familiarize himself. He may still have some queries for you about his ability to answer, but I think that might be a fair way to deal with it.
Okay, so we'll move on from this.
I'm not suggesting you have to continue questioning until after the lunch break, just that he would have the opportunity.
I promise I won't. So Harrison River sockeye rear in the backwater areas and slows within the lower Fraser River for a period of time before migrating to the Georgia Strait. Do you agree with that?
I have had a discussion with Mark Johannes about this topic explicitly, and he mentioned that to me. I don't know that firsthand, and I don't specifically know where within the lower Fraser they're rearing and how those rearing areas overlap with exposure areas within the lower Fraser. So I'm uncertain about that. I have never seen a map that shows me specifically where the Harrison sockeye are rearing and for what period of time.
Well, that will shorten up my number of questions for you on the subject then.
Okay, very good.
And on to one of the last two questions. Would you agree that the majority of current use pesticides registered for use in BC currently tend to have shorter half-lives, are generally not bioaccumulative, and are for the most part less toxic than their predecessors?
No, I wouldn't agree with that. And one of the things we talked about yesterday, I described that study that we've been working with the United States Geological Survey on, looking at small streams within the large urban centers within the United States, and specifically we identified pesticides, pyrethroid pesticides, as some of the most important most important compounds in the environment that were explaining the toxicity that we were seeing in those small streams. So I know that's an assumption, is that they are less bioaccumulative, less short-lived, less toxic. What we're finding in actual studies in the field is that those assumptions are not necessarily correct.
So then specifically, you would be in disagreement with Mr. Varon in tab 834 at page 6, where he says the majority of current use pesticides, CUP, registered for use in BC tend to have shorter half-lives, are generally non-bioaccumulative, and are for the most part less toxic than the predecessors. So this would be page 6 and VI specifically.
I don't disagree with that entire statement, no. I gave you a caveat that indicated that what we're finding with current studies is that some of these pesticides that we are assuming are less toxic than some of the legacy pesticides are still very important in the environment. The earlier portion of that quote is something that is, in fact, true.
Okay, and then my final question is if you could turn to page 53 of your report. In the middle of the page, so right after the bulleted notes, it says, although the maximum hazard quotients for cadmium, chromium, and mercury were almost certainly influenced by sample contamination issues, and then it goes on to say that there were some results that showed exceedances. My question is, can you describe why the samples were contaminated and how many of them were contaminated?
I'll try. I can't attest to how many were contaminated, but in days gone by, mercury-based thermometers were one of the things that get carried around in the same vehicles that were used to carry around sampling equipment and sampling bottles. And those thermometers sometimes broke. There's other sources of mercury as well. And so in some cases, we expect, although we cannot confirm, that elevated levels of mercury were due to that kind of contamination. The exact number of samples I can't tell you off the top of my head.
Okay, and those are my questions. Thank you very much.
Leadham, initial T, appearing for the Conservation Coalition. I have a number of questions to ask you, Mr. McDonald, and I just want to outline where I'm going to go. I want to go firstly to aspects of your report and focus on what was not said rather than what was said in some instances. Then I want to go with you to the conclusions that you draw from your report. I also will take you to some of the comments that some of the reviewers made, particularly the comments from Dr. Ken Ashley. And then finally, I will end up with going to the recommendations, and I will, my clients like your recommendations. I want to disabuse you of the notion that we're going to take issue with the recommendations, but I want to see if we can expand on them in the way that I'm going to work with you on that.
Oh, I appreciate understanding the direction. Thank you.
So what was not in the report, as I understand it, is any mention of synergistic effects between some of the contaminants that you measured. Am I correct in that?
Yes, that's generally correct. We've tried to use a number of tools that evaluate additive effects, and the assumption is that we've used throughout this report is where we've used tools where we look at multiple contaminants together, we've assumed additivity rather than synergistic effects. So that's absolutely correct.
And just so the Commissioner is aware of synergistic effects, my understanding is that if you have two or more chemicals that function together, the result that they produce is not necessarily additive, but may be independently attainable. It may not be independently obtainable. In other words, if you were to add 1 and 1, often we think, well, you'll get 2. But if you factor in then synergy into that, 1 and 1 doesn't always equal 2. It may equal 2.5 or it may equal 10 or something of that nature. Do I have that correct?
Yeah, and it's just to sort of put a finer point on that illustration is there's an excellent study done by Dr. Rick Schwartz, who was with EPA down in Narragansett, down in Oregon. And what he looked at was the toxicity of PAHs, cadmium, and mercury in sediments, and identified concentrations that would be associated with a 50% mortality to the exposed population in each of those cases. And then when he put those contaminants together, into the same material and then expose the same animals, the effects are much higher than what would be predicted based on the results that were observed for any of the contaminants or the two chemicals together. So that's an example of what synergistic effects could look like in the environment.
And not just synergistic effects as they apply between two chemicals, but also there might be synergistic effects that are being brought about due to rising water temperatures. You may, for example, see that, and we've heard some evidence from other scientists who have preceded you to that particular podium, that water temperatures are on the rise in the Fraser. So you would expect that the chemical effect of some of those contaminants, or the effect of some of the contaminants that you've described, might be elevated with elevated temperature. Is that true?
Yeah, and there's a fair body of information that suggests that as water temperatures increase into the ranges where you stress the exposed organisms, they exhibit higher sensitivity to those contaminants. So that theory is borne out by quite a bit of data in the literature as well.
Factor in the stressors upon the fish itself, upon the sockeye salmon. Contaminants are just one level of stressor. And if you add that stressor to something else such as temperature or any of the other things that we've been talking about, that may have an additive effect or even a synergistic effect. Is that correct?
That's correct.
Now, one of the other things that was not in your report is that geographically you limit the report to the freshwater environment, to the Fraser estuary, and up the Fraser to the headwaters of the Fraser. Is that correct?
That's correct.
And so missing entirely from the report are any contaminants from the marine environment. Is that fair to say?
Yes, that's correct.
And we know that there are many sources of marine contaminants through the area through which the sockeye migration pathway runs. Is that not fair to say?
Yes, that's correct.
There's municipal wastewater. You've studied, for example, the Macaulay Point wastewater facility outside of Victoria that runs into the Strait of Juan de Fuca, correct?
Yeah, that's correct.
And that's along the migration pathway, as you understand it to be, of some of the sockeye migrating back?
Yes, some of the sockeye either going out or coming back in, yes.
There's also, fish farms can be a source of contamination, correct?
That's correct.
And you've studied that contamination from fish farms in some of the technical reports that you've done. Isn't that fair to say?
I would not characterize my work in exactly that way.
Okay.
Or if I have, I've maybe forgotten that I've done that work.
I'm thinking about, I came across a reference to Kwathiowski Cove. I'm not sure what you were studying at Kwathiowski Cove.
That was a contaminated site that was affected by the presence of an old canning facility there and boat works.
Now, the other thing that maybe not missing, but you reference point sources, things such as pulp mills, municipal wastewater sources, and things of that nature. Do you take into account in your analysis the cumulative effect of point sources? So in other words, if you have 2 or 3 pulp mills emptying into the Fraser River, do you take into effect the cumulative effect from each one of those point sources so that they're all adding to the load?
Only to the extent that the data for example, the water chemistry data might have been collected downstream of all 3 of those and might have provided information on what the contributions of all 3 would be. That said, I think your point is a good one, is that kind of information on the kinds of contaminants that are discharged by pulp mills, or in some cases by other point sources, aren't adequately characterized within the monitoring that we're doing anyway. And so if we don't have the data, we can't very well account for the multiple effects of discharges from 3 or 4 or 5 different pulp mills in the upper reaches of the Fraser, for example.
And from the work that you've done with respect to looking at how industries are regulated in terms of the effluent that they discharge into the environment, and we're specifically speaking about the aquatic environment here. Are you aware of how regulatory agencies approach point sources and whether they take that cumulative effect into account in issuing permits and licenses to discharge?
It's difficult for me to explicitly answer that question, but I'll tell you what I think. And I don't believe that cumulative effects are considered in most cases. One exception might be in the Northwest Territories, where I do a lot of regulatory type work as well. There is starting to be an interest in looking at regional cumulative effects assessment and considering that during the permitting of individual projects. But that's only in its infancy in that part of the world, and I believe that they're a leader in that area within Canada. So I don't believe that that's happening here in British Columbia.
Now, a lot of times in your report, you talk about data not being available, or you went looking, but you couldn't find the source for data for some of the contaminants that you described. Why is it that we don't have that data? Is it just lack of resources and monitoring ability?
Well, I think there's a number of reasons why that's the case. Again, there's spatially, I've identified a number of challenges in terms of accessibility of the data. And so one of the problems is that the data that we needed to do this evaluation really wasn't anticipated when designers of monitoring programs did their work. So they had other purposes for their data. Not even for the data that is being collected. So that's number one, is the spatial context. Two is sort of the range of contaminants that we're talking about, and typically the monitoring that is being done is for a very limited suite of contaminants. So it's conventional variables, it's for nutrients, it's for metals, and then once you get beyond that list of three, then the list of variables gets pretty short. And so that's problematic when you're looking to evaluate the effects of the inventory of 200 plus contaminants that we identified in this study. And then data are being collected by a variety of different agencies and organizations around British Columbia and around the Fraser River Basin. One of the challenges is that right now I don't believe we have a systematic way of bringing all that information together in one place where it can be accessed to do these kinds of evaluations. So the combination of those factors is sort of what leads us to the place where we're at. And also, of course, one last thing, of course, is that even where very good data have been collected in the past, I'm not convinced that in all cases that data has been translated into a form that can now be used in contemporary assessments. So, for example, and we may get to this later, there was a lot of very good data generated under the Fraser River Action Plan. Not all of that is electronically available easily. Or at all, in case we've asked for it and didn't get it. And that's problematic, where we have historical data. Having this temporal context in these evaluations is very important when we're trying to look for factors that are influencing declines over an extended period of time. If all we have available to us is data for the last 10 years, it's very difficult then to evaluate what the potential impacts of contaminants are over a protracted period of time, where we have healthy populations and declining populations, if all you have for many, many contaminants is just for the most recent time period. So together, these challenges create a situation where we don't have the information that we need to do a comprehensive assessment in the kind that we tried to do in chapters 4 and 5 of this report.
My understanding is that specifically you limited your data usage to digitized electronic data sets that were available to you, and that you eschewed the paper records and the Fraser River Action Plan records, for example, that Canada produced some 10 years ago. You basically were told not to use those data sets.
Nobody told us not to use anything.
Okay.
as I've structured our investigation temporally in the time that we had available, we identified what we could do and what we couldn't do effectively. And so we relied primarily on data that were electronically available. In some cases, we also used some hard copy data, but that was a relatively small proportion of the overall information that we used in our assessment. So your statement is generally correct, yes.
What the report is lacking in, and I'm not faulting you for one moment. I mean, you had terms of reference and you could only work with the data that you had available to you. And I want to now focus upon some of the conclusions contained in your report. And I want to begin by asking you to turn to pages 71 and 72 of your report, where you, under Chapter 5, you have a summary of the evaluation of the potential effects of contaminants of concern on Fraser River sockeye salmon. And I'm going to begin by looking at page 71, about, I think 6 or 7 lines down from the top. I find this sentence: the results of this assessment indicate that exposure to contaminated surface water and sediment or accumulation of contaminants in fish tissues pose potential hazards to sockeye salmon utilizing spawning, rearing, or migration habitats within the Fraser River Basin. Then you go on from there and you say, more specifically, these results indicate numerous contaminants of concern occur in one or more habitats at concentrations sufficient to adversely affect the survival, growth, reproduction of Fraser River sockeye salmon. And then you itemize them, TSS, which I think is total suspendable solids.
Yeah, total suspended solids, that's correct.
6 metals, and then you talk about them: aluminum, chromium, copper, iron, mercury, and silver, and phenols. So that was I draw that, or I found that, and I thought, well, that's one conclusion that you draw from your report, that there are some contaminants which are of concern, specifically to Fraser River sockeye salmon. Is that fair to say, based upon those 2 sentences I just read to you?
Could you say it again? I didn't quite hear you over the siren.
You have the same hearing disability I have.
There's a
I only
certain
hear out
range
of
that's
one
very
ear, and so
difficult.
when there's ambient noise, I sometimes don't always hear the question or the answer. All right, so I read to you 2 sentences specifically from your report, and the question was, obviously the focus of this inquiry is Fraser River sockeye. And so I take it from those 2 sentences that there are contaminants, and you've itemized them there, that are of concern specifically to Fraser River sockeye, that we should take note of, that we should say that that's important to recognize that those contaminants can affect Fraser River sockeye at some stage in their life cycle.
Yes, that's correct.
On at the bottom of page 71 to say, exposure to contaminated sediments also has the potential to adversely affect sockeye salmon in the Fraser River Basin. So you're saying that not only are there problems with some of the surface water and the contaminants that are found in the water itself, but also the contaminated sediments pose a potential hazard to Fraser River sockeye.
Yes, that's correct.
Right. At the end of the day, though, you say that this is a contributing factor to the overall decline in sockeye that we've been hearing evidence of, but it's not necessarily the primary factor. Do I have that right?
Yes, that's correct.
The last paragraph, if I look now at page 72, and this is the same, I'm going to show you the same sentence that Counsel for the province took you to as well, but in your executive summary, you say accumulation of contaminants in fish tissues. So now you're specifically focusing upon what you will find if you dissect the fish out and actually do a sample analysis of what's contained in the fish tissue itself. So you say accumulation of contaminants in fish tissues represents a potentially important factor influencing the status of sockeye salmon populations in the Fraser River Basin. And you go on to say the results of this evaluation show that selenium and 2,3,7,8 tetrachlorodibenzoparadioxin toxic equivalents, I'm going to stress that toxic equivalents because I'm going to come back to that, occurred in salmon eggs at concentrations sufficiently to adversely affect sockeye salmon reproduction. So that was also a conclusion that you reached, is that correct?
That's correct.
All right, well, let's go back in your report to determine what are toxic equivalents, just so we understand that. And if you flip back to page 70 of your report, in the paragraph beginning in 2001, the reference to Kelly, you'll see that the second or third sentence in that paragraph, you say the concentrations of PCBs, polychlorinated biphenyls, PCDDs, polychlorinated dibenzoparadioxins, and polychlorinated dibenzofurans were measured in each tissue sample collected, with the results expressed as 2378 tetrachloro TCDDs, toxic equivalents. So when you're using toxic equivalents, you're also referring to PCBs, PCDDs, and PCDFs. Is that fair to say?
That's correct, yes.
Now, PCBs, polychlorinated biphenyls, have been with us a long time. They're the substance that are found in electrical transformers. Is that right?
That's correct, among other things, yes.
Right. And so they were present in the environment. They're also something that's very persistent, aren't they?
Yes, they are.
In fact, they have a half-life of centuries. I think we talk about those kinds of things having half-lives of centuries, so that they degrade in the environment, but at a very, very slow rate. Is that right?
That's correct.
So once they're present, they're pretty well present for a very long time.
Yeah, in some of our PCB contaminated sites, it's 2011 now. Discharges there probably ended around 1977 or so. We're still detecting very highly elevated levels of PCBs at places like the Hudson River, down in Choccolocca Creek in Alabama as well. These are places where, in some cases, remediation is just now starting to get going on to remove those PCB concentrations, elevated PCB concentrations,
So
because they're not going anywhere by themselves.
right. So even though BC has banned PCBs and using PCBs, nonetheless, they are of environmental concern because of their persistence and the fact that they were used and they stick around. Is that right?
That's right. They're slowly degraded in the environment.
So back now to 72. So basically, you draw the conclusion that the fish tissue samples show that selenium, and we haven't talked too much about selenium. Is this a metal?
Yes, or metalloid, depending on how you look at it. Yes, that's correct.
Is this a naturally occurring substance, or is it found in wastewater discharges? How does selenium come to be in the water?
Yeah, well, it's a naturally occurring substance, and it can, where we see particular elevations of selenium is in the vicinity of coal mining facilities. That's a very common place to have elevated selenium levels. But other places where you're processing ore or other mining or processing ore, that's another possible source of selenium beyond coal mines, hard rock mining potentially as well.
All right, so selenium and the 2378 TCDD toxic equivalents are occurring at concentrations sufficient to adversely affect sockeye salmon reproduction. And then you go on to say, in addition, 2378 tetrachlorodibenzoparadioxin toxic equivalents are predicted to reach levels associated with egg mortality in upriver sockeye salmon stocks. And the prediction there, where does that come from? Does that come from the De Bruyn paper?
That's correct.
Then you say, while the magnitude and extent of such effects could not be determined with the available data, bioaccumulation mediated effects could be important contributing factors to the decline of sockeye salmon in the Fraser River Basin over the past 2 decades. And then you finish off by saying, in particular, the interactive effects of elevated water temperatures, infection by various disease agents, and bioaccumulation of toxic substances warrants further evaluation.
Yes, that's correct.
Those are still your conclusions today.
Yes.
Look to Chapter 6, page 118. Under the heading 6.4 summary, that's where you summarize your findings with respect to the potential effects of the endocrine disrupting chemicals and contaminants of emerging concern. Is that right?
I'm just catching up to you, sorry.
Page 118, 6.4 summary.
Yes, that's correct.
Begin by referring to the fact that we have insufficient data available to evaluate the relationships between exposure and response for any of the endocrine disrupting compounds and contaminants of emerging concern that were identified in the Fraser River Basin. Would one of the reasons be that for insufficient data is because these are relatively new chemicals, so there have yet to be sufficient studies to determine how they are interacting with fish?
Yes, that's one of the reasons, yeah.
What are some of the other reasons?
That we may not have targeted. So some of the endocrine disruptors aren't new to the scene. They've been around for quite a long time. Things like the PCBs, for example.
Yes.
And I think we just simply haven't targeted our research in that area to be able to generate the required data. Even though we've known that there are potential problems, we haven't targeted our research to determine what the magnitude of those problems are.
As a consequence of the insufficient data, you say, therefore, it is not possible to conclude that exposure to these contaminants caused the declines in the abundance of Fraser River sockeye salmon over the past 2 decades, or the low returns of Fraser River sockeye salmon in 2009. So you say you can't conclude that, but you can't rule it out, right?
That's correct.
And you go on at the bottom of the page, you say, you talk about Harrison River and saying, well, if you focus upon the Harrison River, that's one stock or one conservation unit that seems to be doing relatively well. So if they're, and I guess the argument goes like this, if they're doing well and they're exposed to the same sort of contaminant array that other fish are, that the other conservation units are exposed to, then maybe it's not the contamination that is causing the decline. Is that sort of how the argument goes?
Yeah, that's the logic. But again, we don't know what the exposure is for the complex of sockeye salmon is as a whole within the Fraser, or for individual stocks. And so, that's the logic that was used to develop that argument. But that, if, for example, the Harrison River stocks had differential exposure compared to other stocks, then that would be we may draw a different conclusion as a result of that. And so the lack of exposure information is really a key factor that is preventing us from making conclusive statements about what the potential effects of these EDCs and other contaminants are.
At the bottom of page 118, you say, nevertheless, traditional knowledge compiled by the Siska Tradition Society in 2009 on physiological indicators reveals that the length, the weight, and the girth of sockeye salmon have changed over the last couple of decades. So we don't know if it's contamination that's causing this observation or not, do we?
That's right, we don't know.
But we do know that that observation is a valid observation, that traditional knowledge and the First Nations observance of the fish that they're eating is a valid observation, and something obviously is causing this.
Yes, it's very important information.
But we don't know what it is.
Correct.
Now, over at the page at 119, you talk about some of the observations in Siska, and then you say in the first full paragraph on that page, you say, overall, the results of this evaluation also demonstrate that the contaminant exposures cannot be discounted as a potential contributing factor for responses of Fraser River sockeye salmon over the past 2 decades, and or for the low returns of sockeye salmon to the river in 2009. So once again, we relegate this to a possible contributing factor, not necessarily the sole cause, but we can't rule out how this has affected the sockeye, how the contaminants have affected the sockeye. Is that fair to say?
That's correct, yes.
I want to now move to some of the comments that were made by the reviewers to your report. And you can find those in your report at beginning at pages A3. And I want to begin with the first reviewer is Dr. Rutledge from Simon Fraser University. You're familiar with him, are you?
Yes, I am.
At page A4, item number 4, under the heading, the question was asked of him, of Dr. Rutledge, are the recommendations provided in this report supportable? Do you have any further recommendations to add? He says, I believe that the recommendations are well supported and have no further ones to add. The issue of cost will inevitably arise, though, and that's what I want to focus on. And when we get to the recommendations, I'm going to flesh this out a little bit. Some of the things that you're recommending are going to be costly. I mean, every time you take a sample, it's going to be costly, right?
Every time you do something, yes, it costs some money.
So Dr. Rutledge is concerned about cost. Are you concerned about some of the costs associated with the recommendations that you're making?
Well, I'm personally not going to be paying. If it was coming out of my pocket, I would be probably even more concerned. Clearly, there is a limited number of resources that are available for doing environmental monitoring.
Right, and that's simply the point I'm trying to make as well. And he goes on to say, much as they are all desirable, someone will have to identify priority items. And I find that suggestion eminently sensible, that somebody has to start to identify, well, if you only have a limited source of money, where are you going to be spending this money? Do you agree with that? That someone should be there making those kinds of decisions?
Someone will always be there making those decisions, yes.
And it's usually the person that is forking out the money that makes those decisions.
Typically, that's correct.
That's not necessarily the best of all possible worlds, is it, though? If the person paying the money is always the person making the decisions of where the money gets spent.
There are situations where that could work very well, and there are other situations where that might not work quite as well.
Well, I want to move on to another reviewer. The second reviewer was Dr. Sonia Saxida. Are you familiar with her background at all?
I'm not, no.
At page 8, she has this comment about the middle of the page. She says, the author is focused primarily on contaminants in the freshwater phase. She uses FW, I take that to mean freshwater phase.
Yes, that's correct.
Are there any concerns in the marine environments that should be considered? And your response is yes, the potential effects of exposure to contaminants in the marine environment needs to be considered, particularly in the Strait of Georgia, where there are discharges from various municipal wastewater treatment plants and industrial facilities. Such an evaluation was beyond the scope of this investigation, however. So your response is still valid today, is it?
Yes.
And we talked about that earlier. I won't go through it again. And then the third reviewer was Dr. Ken Ashley. Are you familiar with Dr. Ken Ashley's background?
Yes, I am.
And he was a fisheries biologist and was an employee of the Ministry of the Environment for many years, was he not?
That's correct.
That's the Provincial Ministry of the Environment. Now, under the first item, identify the strengths and weaknesses of this report, he says the weakness of the report, I'm now reading under the first response, no response required. He says the weakness of the report is that it could only report on available data. and many of the potential contaminants in the Fraser River drainage have incomplete data. Hence, it was not possible to assess the magnitude of their potential effects on various life history stages of sockeye salmon. And he says, for example, no data was available on the volume of effluent discharges from wood preservative, seafood processing, and most major mining operations. Is he correct in that?
Yes.
Skipping now to page A13, under the heading number 5, what information, if any, should be collected in the future to improve our understanding of the subject area? He says, obtain the information to fill in missing effluent discharge data gaps on industries that were not available for this report. And he goes through those same 3 that we just looked at: wood preservative, seafood processing, and most major mining operations, and determine if the type and volume of effluent discharge could contribute to the 20-year decline in stock productivity of Fraser River sockeye. And you thought that suggestion was a good one, did you not?
I did.
And when we get to the recommendations, we'll see how you've incorporated his suggestion into your recommendations. And then he talks about a new field of toxicogenomics and gives a couple of slides there. Are you familiar at all with this emerging field? Would you be able to give some evidence to us about toxicogenomics?
I would not consider this to be one of the areas that I would comment on.
All right. But certainly to the extent that this sounds like an interesting area, you thought that it would be worthwhile to pursue in terms of a further studies and further research. Is that right?
Yeah, and it's something that with our partners at the Army Corps of Engineers, we're starting to bring into some of the other studies that we're doing at our contaminated sites in the United States. But it's very much at the preliminary stages right now, and so it's hard for me to comment very much on it. It's hard for me to more specifically identify how the results of this kind of work compares with the results that we get from more traditional types of toxicity-based studies.
Well, given that answer, I'll have to just file that for hopefully another researcher or someone. I know Dr. Miller is coming to talk to us about genomics, and this is an interesting way to approach the whole field of toxicology, Mr. Commissioner, that I may wait and see if I can take it up with her when she comes to testify. So now I want to turn to your recommendation section, and that's where I'll spend the rest of my time with you. And I find those if I turn to page 140 of your report. And I've numbered these. I know you've got them in bullets, but I numbered them as 1 through 9, corresponding to the bullets. So the first one, you talk about effluent monitoring programs for all industrial sectors should be reviewed and evaluated to determine if they provide the necessary and sufficient data to characterize effluents and evaluate effects on aquatic ecosystems. So why specifically are you saying that? Is there a problem with how monitoring programs are now being conducted by the industrial sector?
Well, as we talked about yesterday, fairly briefly, we talked about, and I think we used the mining industry as an example of where we identified the number of variables that were included in their monitoring required under their permits. And when we looked at those requirements and then compared them to the list of contaminants that were likely to be released into the environment from, in that case, the mining sector, what we found was that what was required in the monitoring program was only a subset of what potentially could be released into the environment. And so when I say we need to review those kinds of monitoring programs, we need to look carefully to make sure we're monitoring the right things, we're getting the right data on the right variables and the right, frequency and locations to be able to evaluate what the potential effects of those discharges are when they're released into the environment.
And the single database, why is that so important?
It's to provide accessibility to the data. So the data can be broadly accessible to anyone who needs to be doing these kinds of evaluations.
So not just to scientists, but to members of the public who may take an active interest in this.
I can't think of a reason why we would not want to make data available to everyone.
Your second recommendation is routine monitoring programs. And I'm going to suggest to you that one way that we can actually make this happen is to get the various NGOs, the stream keepers, and the First Nations who are actually present at headwaters and who are available to, whose traditional lands may actually overlap some of these spawning areas, to take control of some of these monitoring programs or to allow them to do the monitoring programs. Would you think that to be a good suggestion?
Well, what's interesting about that suggestion is it's similar very much to what we've been, we're just developing sort of that capability in the Northwest Territories right now. We just had a traditional knowledge workshop where we brought together representatives of Aboriginal organizations from throughout, in that case, the Slave River Basin, and identified what needs to be monitored to evaluate, in this case, the cumulative effects of things like oil and gas development, tar sands development, oil sands development, hydropower operation in the Peace system, and other industrial discharges to the Peace Athabasca system. And one of the strong recommendations that came out of that workshop was that this type of monitoring should be conducted by the people who are living in that area and who are most likely to be affected by the those adverse effects of the discharges into that system. Those are the resources that they're using every day, and they're familiar with them every day. They're watching those resources every day. So it's a very reasonable suggestion to indicate that kind of a model could be used in the Fraser River Basin to provide the kind of cost savings. And I think there's two real advantages. One is the cost savings, but more importantly, I think that the quality and timeliness of the data is also likely to be enhanced by being able to have that data collected by the people who are right there observing the resource every day.
Right, so you can envisage that this monitoring program will be done by local communities, be they First Nation or otherwise, because they're mostly concerned about their individual streams. You probably are familiar with environmental groups who are stream keepers and people who walk along the streams looking to observe whether debris is being deposited and things of that nature. And so this is just simply adding an overlay to that of having them also take some water samples and send them off to a chemist for analysis.
That's correct, yes.
Then you talk about the monitoring programs, these routine monitoring programs in your next recommendation, saying what they should entail: water quality, sediment quality, and fish tissue quality. Are these things difficult to obtain as samples?
No, they're not. And by that I mean that people can be trained to do this kind of sampling correctly in a relatively short period of time.
Right. Your fourth bullet also embellishes the monitoring programs that you've just been discussing, or we've just been discussing, and you single out that there's some contaminants of concern in each area of interest, and you identify those in Table 8.1. And then you say near-term priorities should include total suspended solids and stream bed substrate quality, monitoring in incubation habitats, nutrient monitoring in rearing habitats, and dissolved metal monitoring in all habitats, and then selenium, polychlorinated biphenyls, and PCDDs and PCDFs in all habitats, and then monitoring of fish tissues. So when you say near-term priorities, does that mean in the immediate future? Is that what you're referring to there by near-term?
Yeah, I think we have an immediate need for that kind of information on what environmental quality conditions are like within these habitats if we're to resolve this question about, what are the factors that are causing or substantially contributing to the decline of Fraser River sockeye. If we're serious about answering that question, I think we need to get the data that are required to answer that question. So yes, that's what I mean by near-term priorities.
And then, if I have time for one more, Mr. Commissioner, your fifth item down is ambient monitoring program should also include direct measures of effects on sockeye salmon, such as morphology, physiology, and root mortality, pre-spawn mortality, and egg viability. These are some of the things that we expect First Nations to have available through their traditional knowledge base. Is that fair to say?
Yeah, it's for this bill, it's a combination of traditional knowledge and contemporary Western science, bringing those together. It's hard to evaluate, for example, en route mortality unless you have information on what you start with and what you end with. And so you need to have sort of that kind of monitoring integrated over the basin. But these other kinds of things related to morphology and physiology that can be determined in much the same way as has been done in some of the data that we've been able to use from the Cisco Tradition Society. Those are the kinds of things that can be done by people in the field in the area where the fish are actually spawning.
All right. Mr. Commissioner, I'm ahead of schedule, and I expect that I'll be less than the time that I've allotted.
We will now adjourn until 2 p.m.